We want to describe a transformation that maps O onto A. Now, I've clearly got an enlargement because O, this side here is 2 and the corresponding side here looks like 4. So let's just mark that in. So that's 2 and that's 4. And this side, which is 4 over here, is 8. But the problem is not just a straightforward enlargement, because what's actually happened is I haven't just enlarged. An enlargement, the right angle will be here, and in my enlargement, the new right angle would be still on the bottom left, but it's actually like it's turned around as well. So initially it looks like it's an enlargement and a rotation. And what's actually happened is when you've got this kind of enlargement where it turns the shape around 180 degrees as well, where it rotates, we can describe it in one simple movement as still an enlargement. The scale factor goes from 2 to 4 and from 4 to 8. So the scale factor is 2, but I'm going to put a minus in front. So when you see an enlargement with a scale factor with a rotation as well, it's actually got a negative enlargement. And just to show you here, if I pick those points and I do the enlargement using the program, and I'm going to make my scale factor -2, and I'm going to leave the construction lines in so you can see where the center is. Okay, it drew it over this one. So this is very important. The transformation is actually a negative scale factor if it turns it around. Now, just to emphasize something, if I take another triangle and I'm going to rotate this triangle by 180 degrees, let's take the triangle and let's do a rotation. And we're going to do that rotation by 180 degrees. We don't need the construction line. There's the rotation. Now I'm going to take the same triangle and the same center point, and this time I'm going to choose enlargement, and I want to keep it the same, so I'm going to use -1, and you'll see that it draws in exactly the same place. So an enlargement by a scale factor of -1 and a rotation by 180 degrees are the same thing.